원예농업 기술의 최첨단 솔루션을 소개하는 글로벌 박람회 그린테크 2024가 네덜란드 암스테르담에서 개최가 되었는데요. 스마트팜 연구개발사업단도 올해 그린테크 박람회를 참관하였습니다. 2014년 네덜란드에서 첫 개최된 그린테크는 지속가능성 및 친환경 기술 분야에서 중요한 역할을 해온 국제적인 행사로, 이 전시회는 원예산업의 전문가들, 기술 개발자들, 그리고 지속가능한 농업에 관심이 많은 사람들이 모여 최신 동향을 공유할 수 있는 중요한 행사이며,
시설원예 및 스마트팜 분야의 세계적 선도 업체 약 543곳의 회사가 참가하고 1만 2천여 명의 관람객이 방문하였습니다.
이번 박람회를 참관한 스마트팜 연구개발사업단은 첨단 스마트 농업과 관련된 기술을 중점적으로 봤으며, 이를 통해 앞으로 우리나라의 스마트 농업이 나아갈 방향을 엿볼 수가 있었는데요. 그 첫 번째는 바로 에너지 절감 기술입니다. 스마트팜의 첨단 온실을 보급 확산하고 이를 운영함에 있어서 가장 큰 걸림돌이 되는 사항이 에너지 관련 비용을 들 수 있는데요. 이에 대한 해결책으로 에너지 투입의 효율을 극대화하는 시스템과 대기 중 이산화탄소를 포집하는 기술, 그리고 공기열 및 지열을 히트펌프를 활용하여 에너지를 저장하는 시스템 등의 기술들이 이번 전시회에 소개되었습니다. 그리고 두 번째 기술은 양액, 즉 수분과 비료 등을 재활용하는 부분인데요. 네덜란드에서는 수경 재배 시 양액 재활용을 위한 순환식 수경 재배 전환을 2004년부터 법제화했기 때문에, 이에 따라 고도화된 관수 제어 시스템과 고성능 역삼 투합 시스템, 초미세 여과법 등을 소개하고 있었습니다. 그리고 세 번째는 첨단 무인화 자율 재배의 온실 관련 기술이 되겠는데요. 자율적인 운영 제어와 효율성을 제공하는 기술은 기존의 관행 농업을 탈피하여 인건비 절감 및 숙련도의 문제를 해결할 수 있을 뿐만 아니라, 작업 자동화를 비롯해 작물 관리 전략을 제공하는 시스템과 AI 기반의 에너지 및 자원 사용량 절감 및 수확량 증대 기술을 소개하고 있었습니다. 이런 기술 동향에 발맞춰 2021년부터 농림축산식품부, 농촌진흥청, 과학기술정보통신부가 함께 스마트팜 다부처 패키지 혁신기술개발이라는 국가연구개발 사업을 추진 중에 있는데요. 2021년부터 2027년까지 국비 약 3,800억 원이 투입되는 대규모 프로젝트로 현재 스마트팜 연구개발사업단에서 본사업을 수행 중에 있습니다. 이에 사업단은 2020년 12월에 설립된 이후 영농 현장에 적용할 수 있는 스마트팜의 실증 및 고도화와 더불어 AI 기술과 빅데이터 등을 활용한 첨단 자율형 온실의 원천 기술 확보를 위해 꾸준히 노력하고 있는데요. 기술 추격자가 아닌 기술 선도자의 수준으로 올라가기 위해서는 연구개발 사업과 더불어 한국 농업의 실정과 규모에 적합한 스마트팜 모델의 제시가 필요할 때입니다. 이를 위해 정부와 연구자, 농민, 투자자들이 모두 다 손을 잡고 스마트 농업의 발전을 위해 다 함께 머리를 맞대고 고민할 수 있는 장이 될 수 있도록 스마트팜 연구개발사업단이 앞장서 나가도록 하겠습니다.
My name is Thom. I work at Cultilene for a little bit more than 2 years now. Before, I used to work at one of the biggest propagators in Holland, which had 70 hectares of greenhouse only for propagation. And I was responsible for the germination and grafting of vegetable plants. The overview of this presentation, overview on the stone wool production process. Then afterwards, the products that we have at Cultilene, finally the propagation process, so everything from one till the final step of the stone wool. How is it made? It's important to know. Stone wool production process itself, it's a substrate that is made out of, the name says it, stone. There's a mixing of raw materials. It's heated until 1500 degrees, which also means it's very clean. You can see here it's several materials are mixed. It's made into actually lava. It's directed over these spinners, which rotate very fast. And then they produce, when they touch these spinners, they produce fibers. All these fibers are collected. Wetting agent is added, also a binding agent is added. It's compacted into the correct density, because it's different for slabs and for cubes. And then the stone wool can be processed into a slab. What is stone wool exactly? It's 95% air. The other 5% is organic matter. And the organic matters are basalt, type of stone, also made of cokes or slags. That's a byproduct of the steel melting. Like I said, binding agent, wetting agent, there's always a fixed ratio between binder and wetting agent. So this is the transformation process, how we do it in Holland. The stone wool is produced in Czech Republic. It's another country in Europe. We transport it to Holland. This is how it enters the factory. We process it into ore blocks or the slabs, which you can see here. It's cut. One board is cut for each slabs. The products that we have, I want to give a short overview because we have one total system. Most of the crops, they start as a seed in a plug. After a while it goes into a block, and that's the propagation. When a plant is finished between 40, 50, 60 centimeters high, the vegetable producer buys the slabs and the whole system comes together. Plugs, what's very important because the sowing, also the selection of the plants, the grafting also, and the transplanting, it's more and more done by machines. So the sowing is automatic, selection is automatic, grafting is always getting automatic, and also transplanting even. So the plugs have to be really high quality, uniform, but still a good environment for the roots to grow. And that's exactly what the Cultilene plugs can do. They're very uniform, so each plug has the same water holding capacity and also still enough air and oxygen for optimal germination. So how many stone wool there is in a cubic meter? The plugs are the highest density, then the cubes, and then the slabs. So the cubes that we produce, of course, the main properties that you need to have is you need to have an optimum air and water ratio, for healthy root growth. They should hold enough water as a buffer, but if they hold the water too long, then the plant and the roots don't receive enough oxygen. So the ratio between the two should be optimal. And also, what's very important, uniformity is also important. So each and every block should behave the same way and should have the same characteristics. Some of the cubes that we have, for example, one of them is the PC cube, Plant Comfort. It has vertical fibers. So the fibers run like this, from the top to the bottom. Vertical fibers is easier for the root. That is good for example, cucumbers. It's a universal cube for a lot of crops. And there's a really fast rooting in from block to cube to slab. The other block type that we have is called the Woodmax. The fibers are cross fiber, so it's more horizontal and also cross fiber, and also because the roots come out of the sides, then that's better for tomato. This block especially has the inside of the foil is black, outside is white, because then less sunshine comes to the roots, and so you conserve the roots better. So this is a comparison between the Woodmax and the standard. It's the thing is, the roots on the bottom, in propagation you move the blocks a lot, so these roots get damaged quite easily. If you have a block where the roots stay inside the block more, you can conserve the roots better, and also the roots are higher in the block. Instead of going down fast, they are higher in the block and they are more distributed. This is before they go into the cube. This is after they go into a cube, and putting into the cube we call it transplanting. Of course you have the sowing phase, blocks in germination. After germination you have the seedling selection, then the grafting and pinching. Pinching means taking off the heads, and then transplanting. After transplanting you have the spacing, so you put them wider so they can grow more strong. So just to go into the sowing phase more in depth, what's important for the first stage, you need to make sure that, of course, the plugs, if you're at the sowing line, you don't make the plugs 100% wet. Later there's never a chance, because it's difficult. The best is to have a standard solution DC of 1.5 with a pH of between 5.3 or 5.4, because after sowing the pH increases, so one day after. This usually takes between 5 to 7 days. Usually also after 5 to 7 days we do the selection, so small, medium, large. Check the temperature inside the plug, because it should be between 21 and maximum 25 degrees. Then you get a good germination rate. After wetting of the trays, you can check, okay, 240 tray weighs around 2,350 grams. 252 trays weighs around 2 kilos and 470 grams. You need to have at least 2 on the sowing line giving water, and it has to be quite a lot, because at the bottom of the plug, all the plug, it should not have any dry parts. The first one can be recycled water, but the last one should always be new fresh water, because it's in the beginning you have to make the uniformity. The plug hole is in the middle, and also check if the seeds are in the middle. Then laying out the trays in the glass house, it's like I said, they have to be a little bit elevated, because if they're on the floor, then the seedling selection uniformity is most important. There are always plants that are faster or slower, so after 5 to 6 days you can do a seedling selection, small, medium and large. Depends on if you do it by hand or by machine. If you have a machine, it also depends what kind of machine you have. So it's a little bit tricky. This is an example of a sorting machine. They first push out the plugs, then it's on the conveyor belt. It takes them out, and then a camera makes a picture, and then you can decide, okay, small, medium, large. Usually there is 40% first selection, which is the largest, 40% medium, and 10 to 15% small, and 5% is not usable most of the time. Block spacing and nutrition, after selection you don't put them too close to each other because then they stretch. EC is usually around 2.0 because you start to increase. pH again between 5.3 and 5.4. And what's very important, you have to look at the block. Between if the block is too dry or it's becoming too dry too fast, then you have to water them. But if you water them automatically every day, the plant also gets. This stage is also very important to create uniformity because there is always the plants of different sizes. Grafting and pinching. So that's usually after in the summer 14 days, winter 17 or 18 days. You can graft when the variety rootstock is more than 1.4 millimeters. The rootstock you always make a little bit older because you want the rootstock to be very strong. So what you do 2 or 3 or 4 days before grafting, put them in a cooler area. So the rootstock is purple because it's strong. So if the rootstock especially is strong, the connection is a lot easier. And the healing of the graft is also easier. The grafting climate, you can have very different setup. You can have in a tunnel in the greenhouse, especially in summer, the whitewash, because else there's too much sun coming in. But for example, you can also have a setup like this on the cards with lights, a lot of different systems. But the main thing is always high humidity and really vegetative. After transplanting and the transplanting itself, you need to have a vegetative action because you need to stimulate the rooting from plug to cube. So relatively high and stable temperatures. EC should be around 2.5 or 3.0 that you give in the cube. And then wetting up of the blocks, it's best to do it from the top. It falls on the plant. If the plant has big leaves, it will not go into the block, but it will go to the sides. It will first go into the leaves, then it will fall on the floor. So it's very difficult to get a good water level in every block. So you will create uniformity, or you will decrease the uniformity. You have the spacing. Sometimes they also do the sticking, but it's also with a machine. And if the plants are spaced out, then you can really use growing a lot more. And after transplanting, finally, that's when the growing actually starts happening more and more because, in my opinion, and the thing is with the concrete floors, a lot of tomato growers or pepper growers, they have the problem of too high humidity. With propagators, with concrete floors in the winter, they have the problem of too low humidity. So then it's sometimes even 20% humidity, and if you put the plants there, they suffer. So you really need to optimize your climate and not put them. Yeah, we call it like it's like a desert for them. It's a very dry climate for them. So it's challenging, but it's possible. But it's something that's a big difference between propagation and vegetable growing. And after transplanting, the final stage is the delivery. There should always be a selection of size and plant model. The small plants in one section of the greenhouse, and the other plants in a separate section. But if they're all, you need to clean them and disinfect them very well because they bring in a lot of. And that's it. It's quite a long story, but still thank you for your attention.